looking at environmental factors that can affect herbicide drift, so the factors that are beyond the applicator's control, with the idea being the more we can understand about those environmental factors, then maybe the better we can help curb when the best times are to spray. So back up that with numbers. And one of the pieces of data that I've looked at recently is average hourly wind speeds across the state of Missouri. So on page 43, you should have a page with 5 graphs. Yours should be in color and have less writing on it than mine. I looked at average hourly wind speed, 5 different areas of the state, so northwest Missouri, northeast Missouri, mid-Missouri here in Boone County, southwest and southeast Missouri. And there's a graph for each of those counties. And what I did was I went back and took every April day over the last 14 years and every hour of every April day over the last 14 years, the average wind speed. And I took all that data and summarized it and made a profile or a line showing the what a typical April day would look like, and that's in red. The red line on your graph of interest is the average wind speeds of an April day. So to walk you through the graphs, if you're looking at the horizontal axis or the x-axis is going to be the time of day. So the 3-hour mark is 3 a.m., the 12-hour mark would be noon, 15-hour mark would be 3 p.m., and 24-hour mark would be midnight. And along that vertical axis, or the y-axis, is your wind speed in miles per hour. And what we found when we looked at all this data is that within all of the sites that we looked at over the last 14 years, the average hourly wind speed from about 9 a.m. to at least 3 p.m. in the month of April is above 9 miles per hour. 9 miles per hour being kind of the cutoff for when you should be applying some of these herbicides. And you can see there's a black bar that goes across your graph, and that would be the 9 mile per hour line. So anytime the line goes above that, it's kind of maybe a little too windy to spray. So Dr. Bradley is a fan of using these 2,4-D and dicamba programs as far in burn down applications, which we would be spraying in April, maybe May. And so if you're going to do that, you're going to have to go look at the wind patterns, keep that in mind that it is going to be windier at that time.
Yeah, and that's the point I failed to mention, and she just said it, but I'll just reiterate it. I've said numerous times, and I still will say it right now. I think the best utility of the dicamba resistant soybeans and the 2,4-D resistant soybean is in the pre-plant burn down for mare's tail, giant ragweed, all those kinds of things. Not necessarily in crop later in the year, although it's certainly a tool then, but I think the most utility is pre-plant burn down. So obviously that's one side of the coin, but the other side is what Mandy's showing here, 10, 12 mile an hour winds when we would be doing the pre-plant burn down in April or May. So it doesn't really always mesh together there. The two, it's an oxymoron almost, I guess.
So if you flip to the next page, I'm just going to summarize it briefly. I went ahead and looked at some other environmental factors that are well beyond the applicator or the farmer's control as far as things that affect drift risk. The EPA put out a study in 2006 and listed some factors which are on the left-hand side of that page. And I took the counties that I had done the wind analysis for and kind of used the 2012 National Ag Census data to kind of go compare that list on the left with these counties. And so you can read through the list, the 4 points. That fourth point has a question mark by it. It says more than 8 major crops are cultivated in the county. Basically, only Boone County of these 5 qualified as far as high risk if you have 8 crops. But the EPA looked at this in a different way than maybe we should look at it. They counted all soybean as one crop. And when it comes to herbicide drift potential and with these new soybeans coming off regulation, I'm not sure you can count all of soybean as one crop. You have to count the dicamba soybean as one, 2,4-D as another. And when you start looking at it like that, then all of the counties start getting closer to that 8 major cultivated crops. And that just increases the number of days with risk. So at the bottom of that page, the EPA gave an estimate for every county in the nation based on these 4 points as to how many high-risk days there are during the growing season for herbicide drift. And if your county's not there and you're just curious about the information, let me know and we can get that for you. But I want to switch gears now, finally, and talk about something that's an environmental factor that's a little harder to quantify, and that's temperature inversions. So Talking with scientists at North Dakota State and just reading some of the publications, it seems like as far as environmental factors go, the temperature inversions might be the predominant cause of herbicide drift in many cases. And so what a temperature inversion is first, under a normal day like today, the sun hits the ground is going to emit or radiate that heat, and so the air near the ground is going to get warmed, it's going to expand, and it's going to rise. And then the cooler air is going to come down, it's going to get warmed, it's going to expand, it's going to become less dense and rise. And so you have this constant shuffling of air on a normal day, okay? Well, when a temperature inversion happens, it's going to be start to happen close to dusk when the sun's gone down on a clear night where there's not clouds to kind of trap or contain the heat throughout the night. And what's going to happen is the surface is going to cool faster than everything around it. So it's no longer going to be emitting that heat to the air, and you're not going to have movement, so the air is just standing still. So temperature inversion, usually a sign of a temperature inversion is really reduced wind, a clear night. And what happens is when you're spraying during those conditions, basically the large droplets are probably going to hit the surface that you want. But those smaller droplets that tend to be suspended in the air, in that stagnant air. And so if there's a horizontal wind movement or cloud movement, it can carry those suspended particles off very easily. So I've listed some signs to look for on the next page, which I think is 45. At the bottom of that page, there's 4 things that they say to look for. The presence of dew or frost suggests that the surface is cooler as the water condenses on the leaves. You have the wind speed, clear skies, and then fog. But what I really wanted was a number, like how often does this occur in the state of Missouri? Is it something that we really need to be on the lookout for? So I looked for data, published data, to try to get that for you, and I couldn't find anything. So then Kevin asked the climatologist if he had any data, and he did not have any data. So he sent out an email to his network of colleagues across the US. And the most common answer we got back was, well, that's a really good question. Tell us what you find out about it. So right now we're setting up a long-term project, about a 3-year project, to try to get an idea of how frequent these temperature inversions are across the state of Missouri. And so hopefully maybe this time next year we'll have some very preliminary results about that from April and May.